All right, we are going to go over transformation, so I'm just going to fill in some notes. Just follow along. So the first thing is a transformation is an operation that maps an original figure called the pre-image onto a new figure called the image. We kind of remember pre-image has the prefix pre, which means before, so that's the before image, onto a new figure called the image. On the graph to the left, triangle ABC is the pre-image, and triangle ABC, A prime, B prime, C prime is the image. We always do an apostrophe and it will notate its prime. A transformation can change the position, orientation, or size of a figure. Okay, rigid motion. When a transformation preserves the size and shape of a figure all corresponding sides and angles of the pre-image and image are congruent. So the angles and sides of the pre-image and image are congruent. Okay, pause this if you need to get that typed down. Okay. So examples of rigid motions are going to be translations, reflections, and rotations. Those are the three transformations that give you congruent images. So translation, reflection, and rotation. All right, so the coordinate notation for translation is going to be XY, arrow, X plus or minus H, and Y plus or minus K. H represents the horizontal shift. And K represents the vertical shift. Again, horizontal is this way and vertical is this way. As a reminder, left is going to be negative, right is going to be positive, up is going to be positive, and down is going to be negative. Okay, we're going to do a couple examples here. Okay, so I'm going to graph rectangle QRST with vertices -6, 1. So 1, 2, 3, 4, 5, 6, down 1. There's Q. R, which is -3, 1. S, which is 1, -5. And T, which is -2, -7. Okay, then I'm going to connect those, making sure really quick that I plotted. I see right here that I did not plot my T in my correct spot. So it's always good to go back and double check your work there. Okay, now I'm going to connect those dots using my handy dandy line tool. If you are graphing online, make sure you take advantage of your line tool. That is why it's there. Okay, It says to do x plus 5 and y plus 7. Our x plus 5 means that we're going to move to the right 5. Our y plus 7 is going to be up 7. So I'm moving each one of these right 5 up 7. So we'll start with R. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Put a dot, R prime. Then we'll do Q. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Put your dot, label it Q prime. Then we'll do S. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Put a dot, label S prime. And finally, T is going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Label that T prime. We're going to connect those. We're going to visually look. Do those images look congruent? They do, so we did it correctly. Finally, we are going to write our coordinates. So -6 plus 5 is going to be -1. -3 plus 5 is going to be +2. 1 plus 5 is going to be +6. And -2 plus 5 is going to be 3. Now moving on to our y, where we're adding 7. -1 plus 7 is going to be 6. 1 plus 7 is going to be 8. S prime, so -5 plus 7 is going to be 2. And T prime, -7 plus 7 is going to be 0. So that is how we do a translation. I'm only going to be doing one of these because this is a review. Okay, moving on. Now we're going to work on identifying and writing rules. Okay, so you pick the same letter. So I'm going to do E and E prime. I notice it is 1, 2, 3, 4, 5, 6, 7 to the right. So that would be X comma Y, arrow, X plus 7 because we moved it to the right. Then we moved it up 1, 2, 3, 4. So that will be Y plus 4. Now doing my next one, I'm going to do M and M prime. So I'm going up 1, 2. So that'd be Y plus 2. Then I'm going left 1, 2, 3, 4. So that'd be X minus 4. The important part here is making sure that you go your pre-image to your image. So that is how we identify and write rules. I know it says vector component in these instructions, but we are actually not worrying about the vector component right now. All right, moving along. We're going to review reflection. We're reviewing reflection. Just a second. Pulling it up right now. Okay, a reflection is a flip over a line called the line of reflection. Each point and its image are the same distance from the line of reflection. Hopefully remember it's called equidistant. A reflection is also an example of a rigid motion. So it's going to give you a congruent image. Common line of reflections are over the x-axis or the y-axis. Vertical or horizontal lines in the form of x equals a number or y equals a number. Or diagonal lines, for example, x equals y or negative x equals y. We learned this one, but these are also two. All right. Ooh, scrolled a little bit too much there. Hold on. Let's try one over the x-axis and one over the y-axis. So just as a reminder, This is our x-axis, and this is our y-axis. We have to plot the triangle ABC, so that would be -4, 2. So 1, 2, 3, 4, 1, 2, put a dot, that's A. 4, 7, so that's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, put a dot. And then 5, 1. Then we're gonna connect our dots. Okay, we need to make sure our points are equidistant. I'm gonna do my image in blue. This is 2 away. Ooh, wrong tool. All right, this is 2 away, so I'm gonna go 2 away. 1, 2, put a dot, label A prime. B is 1, 2, 3, 4, 5, 6, 7 away, so I'm gonna go 1, 2, 3, 4, 5, 6, 7. I'll label it B prime. And C is 1 away. I'm gonna label that right there, C prime. Erase some of my work here, that way it's a little easier for you to see. And then we'll connect our dots. And as you can see, this triangle is just a flipped version of itself. To get the coordinate points of our new image, what we're gonna do is we are going to change all of our y values to be negative. So all of our second numbers to be negative. So this would be -4, -2, 4, -7, and 5, -1. Okay, for our y, again, we're gonna do our pre-image in red just to stay consistent here. So we'll do 1, go up 2. Oh, it's not letting me write. So we're gonna go 1 up 2, 2 up 5, 1, 2, 3, 4, 5, and 8 up 3, 1, 2, 3, 4, 5, 6, 7, 8 up 3, and last one 7, 0, and that would be S. We're gonna connect our dots there, and we're gonna go on to the other side and reflect it over. So P is 1 away, so I'm gonna put a dot and label P prime. Q is 2 away, Q prime. R is 8 away, so I'm gonna go all the way over here and put R prime. And S is 7 away, so I'm gonna put S prime right there. Okay, when I flip over the y-axis, I change my x's. So P is gonna be -1, 2. Q is gonna be -2, 5. R is going to be -8, 3. And S is gonna be -7, 0. So again, there for my coordinate notation, over the x-axis is x -y, so you change your y. Over the y-axis is -x, y, so you change your x's. Again, pause this if you need to. Okay, we're gonna try reflecting over a given line. Okay, so number 5, I'm gonna plot my pre-image in red again. So 1, -1 is my first thing. 2, 3 is my next one. And 3, -2 is my next one. All right, so you can see my nice little triangle here. It has me doing x equals 4, so I'm gonna go to where x is 4. So 1, 2, 3, 4, and I'm gonna do a vertical line. Because whenever we have an x equals, that gives us a vertical line. Okay, again, I'm checking to make sure all my points are equidistant. So J is 1, 2, 3, so I'm gonna go 1, 2, 3. And K is 2 away, so I'm gonna go 2 away. There's my line. All right, for my points, what I'm gonna do is I'm just gonna actually pull my points directly from the graph. So J is 1, 2, 3, 4, 5, 6, 7, down 1. L is going to be 1, 2, 3, 4, 5, down 2. I'm sorry, I accidentally wrote that in the wrong place. And J is going to be, K is going to be 1, 2, 3, 4, 5, 6, up 3. There you have it. All right, for reflecting over the y, given y line, we're gonna do this guy right here. So again, I'm gonna do my pre-image in red. So I have 1, 2, 3, 4, 1, 2, 3, 4, C. I got -2, 0, that's D. +4, -3. There's that one. And 6, 1. Okay, and I'm going to connect my dots here. Ooh, that's why it's always really good to use your straight line tool just to make sure you get a nice shape. All right, it says y equals 2, so I'm going to go to where y is 2, and I'm going to draw my line of reflection. Then I'm going to make sure all my points are equidistant to that line. So D is 2 away, E is 1 away, F is 1, 2, 3, 4, 5 away, and C is 1, 2, 3, 4, 5, 6 away. So I'm going to go 1, 2, 3, 4, 5, 6. Okay. And then again, we're going to connect our dots. Okay. You can see it's a reflected image of itself. So yeah, we're actually going to skip this part just for time's sake. And that's how you reflect over a given line that's not the x-axis or the y-axis. It's the same basic principle. Alrighty, so that was reflection. We're gonna move on to identifying the line of reflection. So you just kind of have to look at the picture and guess. So I'm gonna guess right here and check it. So K is 1, 2, 3, 1, 2, 3. So I can see there that this is going to be the y-axis. All right, this one, it looks like it's flipped over this line. So again, for those, you just kind of have to look and guess what it looks like it's flipped over. It's okay if you're not quite there yet. I know identifying the line of reflection is a little bit difficult. Okay, the next thing we are gonna do is we are going to go over rotations, which we actually haven't talked about yet. So this is the new topic for today. Okay, so rotating is a turn. Around a fixed point called the center of rotation. This is usually the origin. The figure rotates at a specific angle and direction. Though the figure can rotate around any fixed point, the most common center of rotation is the origin. In case you don't know what the origin is, it's 0.00 right there. All right, so we have rules for rotating. The first one is a 90-degree counterclockwise rotation. So that's going to be x comma y to -y comma x. What this means is you are going to flip and change the first number. Okay, so again, you're gonna flip and change the first sign. Okay, for 180 degrees, you are going to change both signs. So it's going to be xy to -x, -y. So that means change both signs. So change both. I forgot to mention here, 90-degree counterclockwise is the same as 270 degrees clockwise. Just as 270 counterclockwise is the same as 90-degree clockwise. Okay. All right, for 270, you are going to flip both of them again and change your second number. So it's going to look like this. So again, you flip and change second number. So you just kind of have to continually reference these rules. That's what's going to dictate how we're going to do it, okay? All right, let's go ahead and get started. So this one says a 90-degree counterclockwise rotation. So we are going to be doing this, x comma y, to negative y comma x. So we have to use that rule. So our first one, we're going to flip it and change the sign of the first number. So this is negative 7, 2. C is going to be flip and change your first number, so negative 1, 4. And B is going to be flip and change your first number, so negative 5, 6. Let's go ahead and plot that. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, A prime. Negative 1, 4 is C prime, and negative 5, 6. 6, label it, connect those. You have to manipulate the points before you graph, or you're not going to get the correct image. We'll do our pre-image in red. That's what we've been doing. So I'm going from this point right here. So 2, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. 6, 5 is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And 4, 1 is 1, 2, 3, 4, 1. Okay, and you can see here that your image is kind of turned. All right, let's do our next one. Our next one's 180, so that will be negative x comma negative y. So we're literally just making all of our points negative. So P is negative 2, negative 6. Q is negative 6, negative 5. R is negative 5, negative 1. And S is negative 1, negative 2. Let's plot that. 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5. Put a dot. So that was Q. I don't know why I didn't do P first. So do 1, 2, 1, 2, 3, 4, 5, 6. It's gonna be Q prime. I'm sorry, P prime. I'm getting all brain farty. Why you should take brain breaks sometimes, guys. All right, 1, 2, 3, 4, 5. Negative 1, so that's R prime. And then negative 1, negative 2. 1. So that's going to be S prime. All right, let's connect those dots. A nice little square there. All right, let's plot our original image. You know, that green's kind of hard to see. So our original image is 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 and 1, 2. Yes, and connect our dots here. There you go. Again, you just have to use the rule. That's the only way that you can do these. And a 90-degree counterclockwise is the same as 270 clockwise. 180 is the same as 180. So, all right, moving on. Let's do a 270. All right, so we've got 270 right here. Okay. All right, so for 270 counterclockwise, the rule is that you flip and change your second number. All right, so for J, it's currently 3, 4, so it would be 4, negative 3. K is 6, 4, so it would be 4, negative 6. L is 8, 1, so it would be negative 1, 8. And M is 1, 1, so it would be negative 1, 1. Oh, I apologize. I messed up there. Hopefully you guys spotted that error. I accidentally changed the first one to the second one. My bad. All right. So now let's plot that. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Put a dot. That's J prime. Then we've got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It's K prime. 1, negative 8 is going to be right there. That's L prime. And 1, negative 1 is going to be right there. That's going to be M prime. We're going to connect those dots. Ooh, that was a bad connection. Get our little trapezoid right there. Let's plot our original image. Original image was 1, 2, 3, 4, 6, 4. Oh, that's not right. Okay, L was 8, 1. And M was 1, 1. Connect those dots here. You can see that your image has been turned. All right, so that's rotation for you. You just have to follow the rule. All right. Our last one is going to be dilation. If I can get to it. Sorry, guys. They see me scrolling. Ah, here we go, dilation. And okay, so dilation is an enlargement or reduction of a figure with respect to a fixed point called the center of dilation. A dilation is an example of a non-rigid motion. It does not preserve congruency, however, the images are similar. A dilation produces similar figures. I forgot how to spell there for a second. Okay, figures. All corresponding angles are congruent and all corresponding sides are proportional. Variable for scale factor is K. When K is bigger than 1, the dilation is an enlargement. When K is between 1 and 0, the dilation is a reduction. All right, pause if you need to. We got an example over here of a reduction. I'm sorry, this is an example of an enlargement. I lied. That's an enlargement right there. All righty. If PXY is the preimage of a point, then its image after dilation centered at the origin 0, 0 with scale factor K would be the following rule. So this is our coordinate notation. We have X, Y, arrow, K, X, and K, Y. All righty. Let's go ahead and do a dilation example. So we're going to scroll up so I can have some more space. Here we go. All right, we're going to dilate this triangle. I see K equals 2, so K is bigger than 1, so that tells me this is going to be an enlargement. Okay, I'm going to multiply all of my points by 2, so -5 times 2 is -10. 1 times 2 is 2. For S prime, -3 times 2 is -6. 4 times 2 is 8. And for T prime, 2 times 2 is 4, and -1 times 2 is -2. I'm going to go ahead and plot that. So going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down 2. Going to give me R prime. 1, 2, 3, 4, 5, 6, down 8. It's going to give me S prime. And over a +4, so 1, 2, 3, 4, down 2, it's going to give me T prime. Let's connect those. Already, I feel like I'm doing pretty good because this is looking really big. And it's an enlargement, so it should look big. All right, now I'm going to graph my original. So we're going to go 1, 2, 3, 4, 5, up 1. I think, did I mess up? think Miss Peacock messed up. Oh my Lanta, guys. I think I messed up all of these. I'm so sorry about that. I did not graph it correctly. I'm so sorry. So sorry. You're probably watching this being like, yo, Miss Peacock, you're supposed to go up. And I was like, 1, 2, 3, 4, 5, 6. That was supposed to be up 8. Y'all, I am so sorry. So sorry about that. This is why it's better when you guys are in person with me, because you can tell me I'm making these mistakes. There we go. All right, now let's graph our original image. Again, so sorry about that. I accidentally went down. I was supposed to go up. All right, 1, 2, 3, 4, 5, up 1. It's going to give me R. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4. Did I mess up again? Did I mess up again? Lord, the struggle is real for me today, guys. The struggle is real. Okay, I went over 1, 2, 3, 4, and then down 2, and that gives me T prime. Y'all need some backup over here. But real talk, this is why don't ever get too frustrated with math, because even your teacher makes mistakes. Okay, so then we've got our enlargement and reduction. Make sure you're plotting your points correctly. Don't make the same mistake I did. All right, we're gonna do one more, then we are done with this video, which I know it's been very long. You're doing great. Okay, we're gonna do this guy right here, and hopefully I can graph it correctly. Let's start with our pre-image. So negative 10, 2, so I'm gonna go left 10. 6, 7, 8, 9, 10, up 2. That's gonna give me J. 1, 2, go up 8. That's gonna give me K. 1, 2, 3, 4, 5, 6, up 2. That's gonna give me L. And then negative 2, negative 4. Okay, I'm going slower this time, making sure that all my answers are correct. I don't want to have the same mistakes last time where I had to redo everything. All right, my scale factor is less than 1, so I know this is going to be a reduction. And it's basically the same as dividing all of them by 2. If you don't know how to do that, that's perfectly fine. Please type it into a calculator. So negative 10 times 1/2 is going to be negative 5. 2 times 1/2 is going to be 1. L prime is 6 and 2, so 6 times 1/2 is going to be 3. 2 times 1/2 is going to be 1. K prime is negative 2 times 1/2, which would be negative 1. 8 times 1/2, which is 4. And then last one is negative 2 times 1/2, which would be negative 1, and negative 4 times 1/2, which is negative 2. I'm going to graph those. 1, 2, 3, 4, 5, up 1, J prime. 1, up 4. 1, 2, 3, 4, K prime. 3, 1, so 1, 2, 3, 1, L prime, and the last one's M. 1 down 2, M prime. Okay, let's connect those. Boop, boop, boop. I know I did it right because there's a tiny guy. All right, so this is everything that we have learned so far. Almost done with learning everything for geometry. Rewatch this if you need to. Make sure you really understand everything that we're doing, because we are about to combine all of them next class. Make sure you are asking questions if you have them. You need help on any of those IXLs. Have a great day. Goodbye, everybody. I'm going to see if I can figure out how to stop recording. There we go. Goodbye.